So all of these things are very important, very important. So exploiting application-based, which is module 6, application-based vulnerabilities are that's something we need to deal with and engage them from the point of how these things interact. I was saying that when you join a network to use a service. Now, it may sound boring each time we talk about this, but of course, that's how 100 level is, especially when you're training to be a medical doctor. 100 level is like, guy, we've done this thing before. But bringing it to your knowledge helps balance the platform from which you take off, right? So it is very important to establish these basics. It is from the basics that we take off. Now, why am I making this emphasis? A lot of people are beginning to get into DevOps, develop, DevOps, that's the develop applications. And there are actually standards as regards how these applications should be developed, depending on different frameworks that are replete around the world. However, there are certain applications that are actually developed for people to use, which perhaps are not gotten on reputable stores. So sometimes people release to you the APK files, those application files themselves, the ones that you execute and run on your device. A good example would be something like GB WhatsApp. Now, you can never find GB WhatsApp on any store, any reputable store. Let me put it that way. However, a great number of people used it. And the mannerism of the GB WhatsApp was so stealth and so thiefy, very, as in not straightforward, kind of. Imagine somebody having access to the post that you made and have deleted, or having access to something that you posted and you have removed. Now that's funny. That's dubious. However, it's an application that was developed by someone. So typically, there are quite a number of these kind of applications that are out there that people get. Sometimes you purchase a mobile device and they have their own store, right? Depending on different mobile devices. However, there are two major stores that we know that are considered reputable, and they are the ones for the iOS and then the ones for Android. And typically, they have for Android, they have what is called Play Protect. And for iOS, I don't know what it is they have now, but it is hard for you to put anything in that store if that thing has not met certain conditions. Very important. And the reason is because the understanding here is should somebody download that application and the application doesn't have a mannerism or a structure, a behavior that can fight off basic attacks, then the entire place is messed up. So we're going to be looking at looking at those vulnerabilities that are embedded within applications, and then dive into it from there. Now, let me try to show you what we'll be dealing with. First off, I'm going to spend a lot of time here. That's overview of web application-based attacks for security professionals and the OWASP top 10. Now, OWASP how do I put it? Is a framework, or should I call it, is it a framework now or a standard? Because okay, so let me attempt to put it this way. There's a difference between framework, standard, and best practice. These three. I may shed small light on it as we advance, but it is very, very important to know that on the basis of this, whichever you are engaging, they are usually in the best interest of whatever product will be released. So every um, industry or every industry, every sector have all of this. Frameworks are like a frame, like a guide. Standards are more or less rules that must be adhered to. It normally has consequences if adherence is not achieved. Best practices are usually like advices to say, you know what, it's in the best of your interest, you should do this, you should do that. So these guys came up with that, the OWASP. So OWASP is Open Web Application. Let me get that right. Open Web Application Security Project, OWASP. So it focuses, is actually something that is reviewed very often. And the reason why it needs to be reviewed is because it focuses on critical security risks that could happen to web application. Now, the word web application is becoming very common these days, and here's the reason why. Applications were developed back in the day, well, not like back, I think they still do that, for you to download and install on your device. So there's usually, it gives the focus of the client side. I said this the other day, I'm going to repeat it. The infrastructure or the structure of the internet is such that there must be, if you are joining to enjoy a service, there must be somebody giving that service who is a server. Then there must be somebody who is requesting that service, who's a client. Now, when we say somebody requesting the client, it's not just like a whole computer. For the person to become a client, on the side of the client, there would have to be some, um, I wanted to, yeah, application, I call it application, some software that is either installed, all right, or generated that mimics the requester. So that whenever that client side makes a request, it is seen as, oh yeah, based on architecture, this guy is a client for our service because the language he is speaking indicates that he wants to get access to our service. The server, on the other hand, is also an application which is hosted somewhere, right? So whenever we say a client or a server, it could be anything. It could be on a wristwatch, it could be on a key, it could be on a door. As long as it is one making requests for a particular service, it is called a client. And it would have to have the client side application. Now, the challenge was that devices, based on the requirements for most of these application interactions, most devices fell short. And you'd realize that they keep releasing these devices like every now and then, right? Like mobile devices, for instance. They release them like every other year. And then somebody is buying a new one, and I spent a huge fortune of money to buy one 3 years ago. And I don't expect that I want to buy another one because I have a lot of things to do with resources. And then it turns out they release a new one. And somebody's telling me get a new one. And then you get a notification telling you, well, your phone does not meet the requirement for this application that you want to use or this service. The interactions requires for you to have this level of upgrade before you can use that. So it begins to limit a lot of people with handheld devices. It also is a way of limiting plenty people who don't have the requirements met. So the next focus would be to allow people who perhaps have a browser, right? The browser now is the client side of accessing the net, surfing the net. Right? So most of these applications will now be interacted with online, on the web, instead of having to interact with it with an application installed on your device. So we have a lot of web applications coming, which suggests now that the interaction with the service would have to be online instead of having to be, okay, no, let's put it on the web, not just online, because if it's on your phone, it's still online, right? So it provided the opportunity for a lot of people to begin to do web-based applications instead of device-based, the ones that you go to download from the stores, right? Because the stores, a lot of people are beginning to get them. So make it web-based. And the moment it becomes web-based, we have opportunities for a lot of developers to begin to develop these applications. So we don't begin get problem. So because of that, the vulnerability check became a thing of concern. So the standard or the OWASP, which is the Open Web, let me get that right, Open Web Application Security Project, right? They came up together and compiled what you call, let's say, a development practice. So if you are developing somebody, if you are developing an application, whoever you are, there are certain things you must consider. There are 10 of them. That's why it's written that OWASP top 10, meaning there could be some other at the bottom. Maybe they'll be added. And for now, they are top 10 because they are reviewed every now and then, right? So they are like top 10. I think we're going to talk about them as we advance in the course. But top of my head, they are on the top of the list is called one of the things people need to look at is the failure in access control mechanism for most devices. Access control simply suggests there must be, if, like I said, somebody initiating and somebody responding. So if the person is initiating, how do you interact with that person? How the interaction going to happen? So it's called broken access control, which could be compromised, usually by passing those access methods that you have, right? It can happen. Because typically, when somebody is able to get the credentials to log in, then the person can log in. Is there any other way to check who the person is? Now, these are things that exist within a web environment, right? We have things about the failure of cryptography, right? And cryptography focuses on protection of sensitive data mainly. So, what would contribute to the failure could be the fact that there are weak encryptions, There's what is called key exchange, right? And there is a framework for key exchange, which is called the PKI, Public Key Infrastructure, which requires that whether it is symmetric or asymmetric exchange of traffic, there must be an agreement. So there's insufficient protection of data. Things like perhaps your ATM card, credit cards, right? Things like maybe your personal information when you log on to certain websites, right? Then there's the issue of insecure design. With this focus on weakness in the application's structure in itself. Who is designing it? Does the person meet the standard? Right? Then there's the issue of injection, more or less focusing on how attackers are able to manipulate data, right, by executing some commands through certain user inputs. We have examples of SQL injection. We have examples of cross-site scripting and all of those stuff, right? So we have also security misconfiguration, usually where in the building of the application, right, the web application now, there's some misconfigured security settings, right? And all of these things, there's a need for all of this to be followed through, right? So it makes applications very vulnerable to attack because there must be structure. It's like saying, what we're discussing here now is like saying, in every city, like in my city, there is an agency responsible for proper structuring. They embarked recently on house enumeration, right? So that the house numbers that we used to use before is fading away because they believe that people just indiscriminately numbered places. So, and it was done by themselves, and the agency didn't have the structure. So, in order to ensure that they accord each residence or each building, right, or each infrastructure the proper addressing, they went ahead, went numbered, asked people to come to the agency and tender papers. If you have properly purchased the property and you actually have proper clearance, then please make the papers available. Once you do that, they follow through with numeration or enumeration. And each house, matter of fact, my house now has a different number, right? So I'm going to have to adjust a lot of documents. But then why they are doing that is because they believe that ab initio, the people who perhaps gave approval did that fraudulently, or the houses or infrastructures that were built were not done in accordance to preset rule. So that is why OWASP comes up with these details. Very important, right? Another thing to look at here is, say, for example, outdated components in your tools. When you build, right? The same thing with building, for example. We had an issue in my city some months ago. A school collapsed, and it was unfortunate. Lost a lot of students, pupils actually, not students, children who went to school to write exam. And for some reason, it was found that that particular building was before. I don't know how true, but these are things we gathered that the school itself was built in a compound that was a mining site, and for some reason they stuffed it. Right. So if you're looking at the infrastructure, the building, for example, there must be an architect who approved of it and it was built, and people will look at it from far. Whereas there are documents that capture what the infrastructure is supposed to be. Right. So we're going to take some time in this topic. I'm not going to rush it. Right. So using outdated tools, these tools could include, very importantly, things like framework. Now, these frameworks, like we mentioned, every industry have their framework, and these frameworks are usually revised over time. Right? For example, let's look at the health sector. At some point, 2020, there was a framework that came out as regards being in public places, right? And that was because of the prevalent issue we had. And said you could not be in a public gathering space except there was some amount of spacing between you people. And even if you're going to be in a public space, you have to wear a face mask, to the point that airports had marked spots. So you couldn't cram up against each other. Everybody had to be within there. You get to a place, somebody's selling face mask or got face mask, sanitizer. Then they also had some screens in some airports. So as you're approaching that particular screen, is able to tell based on your temperature that, oh boy, bless this guy, no well, they'll move the person away, right? Now, this framework was applicable 2020. It's not very applicable today. Based on that particular outbreak, that framework was operational then. It's not operational now. Even if they're going to look at it, it has been tweaked, perhaps been improved or revised. So if somebody is dealing with public space gathering with the framework of 2020 in 2024, person is out of space. Bring that now to web application design or development. If somebody is using a framework that was active or that was perhaps considered valid in 2020, right? And the person is doing that today, person might be out of line. So, and another reason is perhaps because it is vulnerable. So outdated frameworks or libraries. Now, libraries contain agreed upon structures, right, that introduce logic flow for development of applications. So if the libraries are outdated, perhaps because they've identified a new, plugin and all of this stuff, and you're using that, it throws open that particular application to attack. So if the attacker identifies that this plugin or this particular library is as of 1992, but it looks fine, but in the structure it is from 1992, it's going to be compromised, right? Then there is with respect to logging in or using the application, there's the issue of identity and authentication, or let's say identification and authentication. Now, this is usually with respect to ensuring that users, that's identity and access management, with respect to using that particular web application. How do you identify users and how are they authenticated, verifying that they are the original or authentic users that they claim to be? Okay, so you could have a weakness within that particular structure. Perhaps the module that they are using is outdated. So these are things that need to be checked based on the top 10 OWASP, right? Then there's also the matter of data integrity, right? And software and data integrity with respect to, or the failure of software and data integrity. Now, it is usually on the grounds of weak integrity control. Let's put it this way, what is integrity? Integrity suggests that what it was, whatever I'm interacting with as an application, as a service, as a process, whatever was agreed upon at the beginning, or even with data or with application, whatever it was at the beginning should remain consistent all through. It shouldn't be changing as we move, whether it is adding fact or taking out fact or adding data or adding some, whatever it's adding, there must be a standard that focuses on the integrity of that particular application or the software as it is, or data integrity, right? Then there is the security, login, and monitoring failures. What happens when somebody attempts to log in? This is very common with a lot of these. How do I call it now? I wanted to call it a name, but it might be very offensive because I don't know if some of you benefit from it. But there was I think we can call it a pyramid. All these laundry pyramids. What they call this now? Something networking. What do they call that thing? That people you put in money, after some number of days, the money becomes a particular number value. You go ahead, withdraw it, and then count and all. What they call it now? Pyramid scheme. All these Ponzi schemes, right? Yes. Let me. Somebody's typing something. Ponzi. Thank you. Ponzi scheme. Very, very. So some of them have applications and they have website and tell you login. So you are meant to believe as long as it's on the web, man, we're good. Now the thing there online, check out. Check our website. And you can just go there and create an account. It's okay, create an account, use your password. Please make sure you log in with this. This is your file number. This is your ID card. Well, all of these things can happen. But what if that site is more or less like a scheme to gather all of this information? Because you have stuff like your email address there, you have your name there. Sometimes you may even have your BVN there, your NIN could be there, depending on all of this. So they can go ahead and extract all of this stuff. So with regards to logging and monitoring, right? And also with regards to those logging and monitoring failures, what are the security? Whether focusing on sufficient logging or monitoring variables, right? Proper logging, real-time monitoring, those things are they available. These are things that OWASP as a how do I put it now? As if I don't know whether to call OWASP a framework now, right? I think it looks more like a framework, right? It looks more like a framework, right? And then lastly, we have what is called SSRF. SSRF is server-side, the server-side request forgery. Now, there's also the client side. We're going to deal with all of those much later with respect to cross-site scripting and the rest of them, right? Now, typically, every server, right, understands that its job is to respond to requests made. Now, in its response, how secure is the server, right, with respect to handling each request? Whenever a client makes a request, right, how is it handled? What if somebody spoofs the request on behalf of the server, requesting some vital information? Or what if an attacker is actually pretending to be some other side? So how does the server handle this? Somebody can actually forge the server-side interaction, like using man-in-the-middle attack and all. Hijack the request made by a client and goes ahead to act like a server, like we talked about yesterday with respect to some other services like IP address services or DHCP spoofing, sorry, ARP request, and also, being able to populate a particular switch with information, MAC addresses that are actually not genuine. So on the server side, how is it handled with respect to vulnerabilities, right? Because this server-side forgery focuses on compromising the server so that it makes the attacker generate requests on behalf of the server. And that way, that attacker can access potential, how do I call it, sensitive information, right? And thereby compromise all the end users that connect to the place. So OWASP is a very is good, and here's the reason why they did all of this. Before we dive into the slides proper, they did that because there was a need to raise awareness between people, right? And if it's awareness, it means that this particular document is going to be reviewed or revised. They keep adding to this document every now and then. Another thing they are looking at is to be able to assist risk management. So in the event that there's a risk, these top 10 are the way to engage. So, okay, if I'm looking at a website or a web application, not site, sorry, web application, right? How do I access it? What are the things I'm going to be looking at to ensure that this guy is thorough, right? The another thing is it also helps developers, right? Have some sort of like a foundation so that they're able to, for the purposes of security, integrate best practices into their development of the software. Every software, of course, has a life cycle. So these are part of what's actually considered when the applications are being developed. And also, very importantly, I don't know that that's the last, but very importantly, let me just pause here. Very importantly, with respect to regulation, every sector or every industry that doesn't have some form of regulation will suffer some serious damage. So this OWASP top 10, we'll call it top 10, focuses on ensuring some form of compliance, right? So that it is with respect to regulatory compliance and, let's say, security governance. There's a word like that. It ensures some level of compliance. So if I'm engaging the services or if you are engaging the venture of developing an application, look up OWASP. Very important. Matter of fact, you couldn't have been in the development world and not have come across it, right? So like I said, it is open web. I don't forget it in again now. I just shall know it every now as OWASP, but it's yes, Open Web Application Security Project. Yep. OWASP, Open Web Application Security Project, right? So there are quite a number of things that it focuses on. The idea is like the overview, right? Most of the attacks that are most prominent or most prevalent on the internet are stuff like your cross-site scripting, injection attacks of all the SQL or non-SQL, um, cross-site request forgery, not the server end now. And there's also IDOR, I think it's IDOR, is direct object referencing, and the rest of them, different kinds of attacks that occur. Right. So with that, that's the part I want to dwell on today, this particular part, the overview of web application based for security professionals. Right. So it's very, 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 very important. Let me mute this guy. Some people don't understand. So yeah, so all be muted. So if you have any question, just lift up your hand, I'll help. So we're going to also look at this particular topic, this particular chapter, how to build your own web application lab. Okay. Understanding business logic flaws, understanding injection-based vulnerabilities. That's why you use tools to conduct injection attacks. I always say this again. As it stands today, I desire strongly that perhaps amongst the people who are here, or even, perhaps in our client, let's have people that develop tools for most of these tests that we're looking at. Because the bulk of the tools that we develop, I agree that we are perhaps not the ones who started, but we can develop our tools. Let's look at the fashion industry in our client. At some point, we used to wear clothes from there to the point that somebody wears, oh boy, but we now have people who make them here, and they're actually sometimes even more durable, except that maybe it depends on how much you pay for it. So it can happen within the IT sector. I believe so. So exploiting authentication-based vulnerabilities, again, using tools to be able to exploit authentication-based vulnerabilities, simply focusing on how that I can mimic somebody who is requesting an attack, requesting login details and all, exploiting authorization-based vulnerabilities. Then we'll also look at understanding, this is where we're going to spend time, which probably like tomorrow, understanding what cross-site scripting is. Those of you who buy power, who buy, what's it called? Buy electric unit from buypower.ng, right? You may suffer some of this kind of stuff because some of your credentials are stored somewhere. And site scripting is simply allowing a continuation of interactions from one site to the other. And some sites actually have it. There's what's expected to be contained as a script within each website. When you allow conversations from one website to move on to the next website, there's usually an issue. What do you mean? Sometimes you're trying to pay for some certain services, right? And you engage, how much you want to buy. Sometimes some of you buy data, perhaps you book airline tickets, you book maybe even buy power units. But at the point of payment, you are sent to a particular site. Yeah. Now that site is not hosted by the person whose services you are engaging. It's just like as far as payment is concerned, it's taking you to a payment gateway. There's some interactions that occur from your site to those payment gateways. So we'll look at how some of those happen. Then we'll look at understanding cross-site request forgery, understanding clickjacking. We're going to explain it, and exploiting security misconfiguration. We're going to explain how that happens and how it is exploited. Then we're going to look at exploiting file inclusion vulnerabilities. Then we'll close with exploiting insecure code practices, right? So these are the things that we'll be looking at. So I've done a good job already with respect to overview of the web application-based attack for security professionals and the OWASP top 10. We're just going to go through it. I've done some good justice to it in explaining it. So let's dive into what we're going to be looking at. So, or let me also say this as we, so as a penetration tester or as a pen tester in training, right? Or perhaps as someone who is adding more, what's it called, more skill or more knowledge to your pen testing journey, it is important to understand what I explained earlier, that interactions with services can be done on web, right? And this is because the applications are now web-based. And the reason is because not every device has the capacity to host the services. Sometimes it might be too heavy. So they let the application to be an interaction that happens with your browser. So web applications use many different protocols, the most prevalent of which is HTTP. For those of you who are very familiar with HTTP, it's Hypertext Transfer Protocol. Some people argue it to be Hypertext Transport Protocol. Well, either which way, it transfers, it transports. Well, but the common name, the name, except that the well-known name is Hypertext Transfer Protocol. Now, this course assumes that you have a basic understanding of internet protocols and their use. But this module takes a deep dive into the components of protocols like HTTP that you will find in nearly all web applications, right? So as long as it is web application, there will be an interaction that occurs, which is on the web. And there's what we refer to as methods. These methods are um, um, rules that each service, right, exchanges between it as a server, or each service requires this exchange between the requesting guy and the serving guy. So in this case, the client and the server. So typically, HTTP has quite a number of, I won't call them tools, components, which are referred to as methods, right? Let's look at that. Now, the HTTP 1.1 protocol is defined in RFC. Now, if you're in IT, regardless of the field, you have to be very familiar with RFC. So RFC is like a document that is a document, yeah, it's a binding document that hosts discussions by gurus or techies as regards a particular protocol or service. So people come up and say, hey, this service is going to be in use. All right, so it's going to be used. Let's get stakeholders, just like drafting a policy. So it's like a policy for things that are used online. They call up these guys, high level guys, they sit down, have meetings, discuss, perhaps do like they do fora, they do perhaps conferences, workshops, and all of this stuff. And they come up with findings. So you have people who are using it, people who are developing it, have conversations, and then they go back and forth about this particular matter. No, it's not going to be good. No, it's good. And developers are there, vendors are there, manufacturers are there, network guys are there, programming guys are there, and they all look at this particular service and they see what aspect they contribute to it. All of this is now drafted into a document and is given a number. So as far as HTTP is concerned, it is captured, 1.1 that is, it is captured in a document called RFC 7230 to 7235. That's 30, 31, 32, 33, 34, 35. All of it contains discussions or deliberations on HTTP. In the examples in this module, when we refer to a HTTP server, we mean a web browser. So typically, this particular protocol works on port 80, and port 80 is for web. Okay, so the protocol that governs web exchange between a client and a server is actually called HTTP, right? Whereas the service itself is web. Okay, so the protocol or the rule that governs web interactions is actually HTTP. So when we refer to HTTP client, please note, that's what I was saying earlier about the client. We are talking about anything that you have that works from the client side, not a device now. They're usually applications. So it could be a browser, could be a proxy, and you all know what proxies are. Proxies are devices or programs that we develop or build that acts on behalf of, right? Could also have an application programming interface, API client. This is where web applications became a thing. Another custom HTTP client programs. So all of these are available, and all of these are scripts, right? So HTTP is a very simple protocol, which is both a good thing and a bad thing. Now, why? It has in its request or in its interaction to get to no, let me know its get in its interaction to use the service. I think they have about 9 methods of interaction. One, there's get. Now, get is usually what a client generates, right? It's that particular word get indicates that this is a request coming from a client side, and the purpose is that it wants to retrieve data from the server. Okay, so of course the server has an IP address, and the fact that it's a browser, right, captures is it capture now? The fact that is a browser, right, in all purpose and intent indicates that this person is attempting to reach a server. There must be an address, identity of that particular guy, and of course it's coming on port 80. But then what does he want to do? As it is coming on port 80 to a particular IP address, what does he want to do? He wants to retrieve data. Then the information that should be along with the request is making should be get. That means it wants to retrieve. Now, these things are very important because typically once you use tools to sniff or to gather information, traffic exchange between devices, you are able to tell what state of this conversation this attack is happening. Get is to retrieve information. Then there's post. Post is usually when the client wants to send data to a server. So there's get, retrieve. Post is to send. Then there's put. Put is usually indicating that the client wants to create a resource or wants to update a resource on the server. So get, post, and put come from the client. Then there's delete, which means remove. And so this one's are things we want to see things like post, things like put, things like delete are things we need to pay attention to. Right. So when we get our information and we're going through all of them using whether it is what is it called? Whether we're using Wireshark or we're using forgotten the name. See, I can see too. Any of those tools, by the way, right? So I'm trying to explain how simple it is, how simple HTTP is. Then there's also patch. Patch normally is attempting to apply some modification, right? Not complete modification, because from the word patch. So somebody could be attempting to reach a server and is patching some resource and is without authorization. Okay. The most common is get. That's normally when you go to get a website or download a website. Then there's also head, which is retrieving header information. Header information are usually the part that contains sender, receiver, and then the protocol that is in use. Then there's also the option, right? There's trace. Trace is dangerous. Trace is typically where a client, right, is attempting to trace the path, right, that a request takes to reach the server as it moves across the path. Then there's connect. Connect is normally very dangerous as well. That's typically when somebody is attempting to initiate some remote connection, right? Establish some connection, like a tunnel connection, usually using either the security features embedded in web browsers like your SSL and TLS. Okay, right. So in most cases, HTTP is categorized as a stateless protocol. What does it mean? What that means is that it does not rely on any form of connection, right, that is persistent for it to maintain some logic, some communication logic. What do we mean? It means anybody can go ahead and just make requests and the guy will respond. Now, when it is stateless, when it is stateful, it suggests that it wants to identify the state. Is the port in a listening state? Is it at a state where it is giving request? Okay. Now, a HTTP transaction consists of a single request from a client to a server. Typically, that's how you should follow, right? So one, there will be a request made from a client going to a server. That request is followed by a single response from the server back to the client. So it should be like that. So this is what it should be. Client makes a request, server makes a response. So it should be single. So why are we saying this? In the event where we observe the server is receiving multiple requests from one address or from one device or from one application or from one service, then of course it raises eyebrows. Okay. Now HTTP is different from stateful protocols, and the stateful protocols are FTP, SMTP, IMAP, and POP. Why? It wants to find out. First of all, there's an initiation to ensure that the guy can provide a service. Then we can go ahead and agree on the size of what's going to be exchanged. That's what makes it stateful, right? When a protocol is stateful, sequences of related commands are treated as a single interaction. Get, right? Or let's put it this way, synchronization, an acknowledgement of the synchronization, then an establishment. So we realize that, okay, this conversation as it is, when we put all of them together, when we are doing some analysis, we can say, okay, this is the source, this is the destination. Look at the IP address and tally them and say, okay, yeah, this conversation is happening between the client and the server, and it's taking this amount of time. So the strings of information exchanged between them are logged together because they identify a sequence, right? Here's what we mean. Let's assume that a client reaches the website and the client says, hey, I want to get this web page. The server says, all right, yeah, I have the web page available. And the web page, the size of the web page is X number of MBs. Client says, I can't take all of this. These are conversations that happen between both of them. I can only take a particular size, and that usually is referred to as a window size. Window size is the amount of the size of a traffic that a particular client can receive or the size that the server can give. Now, based on the capacities of the people doing the conversation, the client and the server, there must be an agreement between the client and the server. This is where it's stateful. So you identify the status of what we're trying to send. I'm going to use an example about this shortly to try to communicate the point, right? So typically, the size that the client can receive per time is called the window size. Now, in each window, there are sequences, right? Each of the things that make up that window are sequenced. So perhaps let's assume he's looking at 10,000 sequence, right, of what he's going to send. Client says, I can't take 10,000, I can only take 2,500. This means that the 10,000 window size will be broken into four, right, 2,500 each. So the server indicates that to the client. Client says, okay, good, I'm cool with that. Then they begin conversation. This means that a conversation has occurred and they are aware of the state of the transaction that should happen between them. So it means the client is now expecting four window sizes as against the one that the server can give. And the reason is because of the agreement between the both of them, right? So the client now receives window size 1 with a sequence number of 1 to 2,500 sent to the client. Client acknowledges receipt of window size 1 with a sequence number of 1 to 2,500. Then he sends an acknowledgement to the server saying, I've received it. The next that I'm expecting to get from you should be 2,501. So if the server responds and that thing doesn't tally, we know there's something fishy going on because they've already had a conversation and the both of them have agreed on what to be sent. So let me use an example. You have a friend who's perhaps in Lagos. I'm in the Middle Belt, and one thing that is very available here, though it's becoming expensive these days, is potatoes, Irish potatoes, and a lot of people crave it. So I have a bag of Irish potato I want to send to you, maybe in Lagos, and I go to the transport company. Yeah, somebody's asking a question. Sorry. No, I see the same slide though. Sorry, are you saying you're not seeing the slide, Ikoyi? You're not seeing the slide? I'm on the HTTP protocol. That's what you should see on your screen. Please confirm that you can see that. Ah, yeah, so good. So we're fine. Okay, great. I think let's continue. So I'm still them, just making explanations. So Ikoyi, I take it that you're in Lagos. So I'm sending you a bag of potato. But the challenge is that you are telling me from our conversation that you don't have the capacity to take a whole bag because the transport company that we're going to be using cannot take one full bag. I haven't discussed the size. So the company will now say, you know what? Because you're not the only person that we're carrying, this is just like an example. I'm not saying that's how it happens to be able to score the point I'm putting across. Company now says, no, this bag of potato, we're going to break it into 4. And we'll have 4 separate transportation vehicles that are going to Lagos. So you are going to be in the know. You shall know that you are going to be receiving potato, but they will not come in one bag. They will come in different bags. Okay, so there's bag 1, bag 2, bag 3. So let's assume that there are like 1,000 or 10,000 potatoes in each bag. So that means you're going to count it. First bag is potato 1 to potato 2,500. The second bag is going to be potato 2,501 to potato 2,000 to potato 5,000. So let's assume that they are all numbered. So that's the sequencing. The window will be the bag itself. And then the sequencing will be the number for each potato inside. So by the time the potato bags now arrive, the transport company, you are going to pick one bag. However, this one bag is scattered into 4 separate places. So you would make sure that you look at the bags and then pile them together to arrive at one full bag. Right, so that's exactly how this happens. Now, it is expected that that's what makes it stateful. The fact that there's a conversation, right? And there are sequences of related commands or related conversation. So we combine them together. So when I see a bar coming from Jos, when you are there at the park and you see a bar coming from Jos, all you're looking for is the IP address or the phone number, right? And then you look at the sequence number and then the tally based on the conversation we had. This is exactly what happens to servers or between servers and client. So once we say a particular service or particular protocol service actually is considered stateful, we're saying that there are conversations that have been had between the two guys. So a server must maintain the state of its interaction with the client throughout the period of transmission until interaction is concluded and terminated. If that doesn't happen, then that particular traffic or that particular service is not stateful. So a sequence of transmitted and executed command is what we call a session. Once a session is existing between a server and a client, there are a series of conversations that can happen. That's like you moving from one page to the other, right? Scrolling and do whatever within there. Once you close that browser, that connection terminates. Now, it is very, very important that as penetration testers, we have this fair understanding. That's why I was mentioning about networking, because it gives you an idea of what attackers attack. Now, this is the typical behavior that occurs for a HTTP server. Okay, so if for some reason somebody's going to do any form of attack, he's going to take advantage of those conversations that you're having. He will make it look like he's generating it or perhaps spoof it. Right? Let's move on now. Sure, it's making a lot of sense now. Now, HTTP proxies, right, act as both servers and clients. Now, proxies make requests to web servers on behalf of other clients. So the proxies enable HTTP transfers across whatever whatever architecture you have that is supposed to provide some form of protection, like firewalls. It does that across the firewall and also provides support for caching. Right? We'll keep some form of conversation that happened before so that once you arrive there, you don't initiate the conversation already. It's like, oh, we already had a conversation with this particular service or this server and it's open. You just continue. So proxies actually make it easy to reach certain sites or certain services or servers, right? And so the idea here is that the proxies have a way of performing roles in complex environment. The roles are things like network address translation. For people who do network address translation is on the basis that it's already been agreed that IP addresses, for the purposes of allowing everybody to use them, are broken into two. There's what's called private and public. Private IP addresses are used within the private environment. Public IP addresses are allowed to be used publicly. A good picture would be understanding what you can wear at home and what you can wear outside. There's certain kind of stuff that you can wear around the house and go around. These are considered private. Imagine you appear in a public environment with private attire. Well, it's happening, but I'm just saying in some sane climb. Just imagine somebody who's supposed to wear stuff privately appear in the public place. Natural thing will be enforcement agent should ensure the person gets back. Within the internet, that happens. So no private IP address is allowed in the public environment. So there's a solution that is introduced to allow private IP addresses be recognized within the LAN at the border, and then the translation is done for them so that the public IP address goes out. Typically, like what's going to happen to a human being. If you have any meeting you need to go to and you're still putting on your private attire, what you do is you put on a public attire, go out, and come back. Let's assume you're in front of the house and somebody knocks at the gate. And then the way you address, you say, you cannot go to the gate like that, being the only one at home. You find something to put on, which is public or presentable, you go outside. That whole process happens within networks, but is on the basis of some configuration. And that's what we call network address translation, right? So, also another thing that happens there is filtering of, what's it called? Filtering of HTTP requests. Now, HTTP is an application level protocol, in the sense that if you look at the OSI model, right, for network purposes now, I think I explained it, being that it's a model that allows for interoperability, also fosters design of network infrastructure, right? We categorize all of these interactions that happen in network according to levels or layers. So say there's a layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7 being application. However, the OSI model is used for better explaining how network operates. However, there's what is called the TCP/IP protocol suite, which is a collection of the rules that ensure that things that happen at layers 1 to 7 are properly done. So application, right, or HTTP is at the application layer of the TCP/IP protocol suite. It uses TCP as its transport protocol. This is a picture I can paint. If somebody has a vehicle and is transporting eggs, right? Another person has a vehicle and is transporting watermelon. They are both fragile, but the way they will be packed cannot be the same. So the transportation method for eggs cannot be the same with the transportation method for watermelon. Let's scale it up a little. I want to also transport goats. Now, the transportation method for goats cannot be the same as that of eggs. Eggs are very sensitive, so I pay attention to it. So the overhead that's going to be added to transporting eggs is going to be more as compared to that of goats, right? Bring it back to IT, or what we're discussing here. At the point of ensuring that traffic that you are generating and interacting with, as services that you're interacting with, are properly structured and transported well, the transport layer has two guys or two rules that handle this. There's a TCP and there's UDP. And this is part of what are very, very important for discussion for pen testing, because you can look at a particular capture and identify what mode of transportation is being used. And with the understanding of the transportation, you can guess or can even predict what's happening, right? So TCP, or Transport Layer Protocol, has two protocols. There's the TCP, which is Transmission Control Protocol, right? And then there's a UDP, User Datagram Protocol. The two are used interchangeably. No, let me put that right. The two of them are used depending on the kind of protocol. No, the both of them are used depending on the kind of service you're interacting with. Some services require stateful conversation. Some do not, right? The ones that require stateful, right? There's going to be a lot of overhead calculating and checking window size, sequence numbers, and all of this stuff to be able to, we call that flow control. So the protocols or the services that require flow control check use TCP. So HTTP is one of such. So it uses TCP as the underlying transport layer protocol for transmitting messages. So HTTP uses a request and response model, meaning what this means is that, I explained that earlier, it means that you have to make a request from the person giving, and the person giving will have to make a response. So that's a model. So typically, just like what we have here, once the session is open, right? Remember, the session is a combination of every interaction that's occurred between the client and the state of the interaction happening between the client and the server. So once that session is open, the connection is now open, then the client can go ahead and make a request, then the server can go ahead and do a response, typically. So it means that a client program will send a request to the server, and then the server returns a message as a response, right? So that's what we have here. Let's move forward. So in this example, there's an application called TCP dump, and this is available for our, what's it called now? Our um, virtual box, right? I'm still yet to download my own. I've been downloading it. It's been breaking for how many days? I don't know what's going to happen. I'm going to use it, not like I wanted to. We're going to do that. What we have here is actually like an output, is a Linux tool. It's called TCP dump, right? It is used to capture packets from between the packet exchange between devices. Right now, in this case, it is a client with an IP address of 192.168.8.6, right? Who's accessing a web server or a website, sorry. And the website is located at web.hacker.org/omar.html. That is the landing page.html. Okay, so you can see the conversation here. It's capture of HTTP request. So this is so it's saying a super user do or sudo TCP dump for this network 185.199.0.0/16, right? So it's listening on this particular interface, and link type is this Ethernet. This is what's going to capture. Then exchange begins. And so you see here there is 185.199.109.153. Most likely the IP address of the server, right? So this is the IP address that is making a request. So if you look at it here, this is IP address of 192.168.78.6. This is the guy. Now this is called the port number. I know you know port numbers. For the purpose of referencing this particular document again, let's put it this way. So port numbers are openings, right, that ensure interaction with services. Now, every service that you're going to use is hosted on a particular port. These port numbers are categorized into three. We have what is called the well-known port, we have the registered port, and we'll have the dynamic port. Now, the well-known ports are for services that are very popularly used around the world. People know them. They are like de facto standards with respect to certain services. For example, for surfing the web, we have port 80. For mail, we have 25. For SSH, we have 22, and so on. For Telnet, 23. These port numbers are well known. Now, registered are the port numbers that if you are a developer, like a vendor or a particular industry or a particular manufacturer or a company or an organization, you come up with a particular service and you believe that a part of the services you are giving requires that people actually interact with this service on this particular port. So you make the proposal to the body looks at it, ratifies it, and then grants a particular port. So those ports are registered, right? So any proprietary port could be Cisco, could be radius, could be Microtic, could be just name them. Any of those proprietary guys, they have their own port numbers. Those port numbers for their services, Microsoft and the rest of them, they have port numbers given to them. They're referred to as registered port numbers. Then the dynamic port numbers are reserved for every host that do not host any kind of service. The ones making requests, they use those port numbers, right? Just like how phone numbers communicate with phone numbers or email addresses communicate with email addresses, it is proper that the services that are hosted on certain ports be interacted with through ports. So the port numbers that are in the dynamic range are the ones that are generated by devices. So what you have here is a port number, right? 37328. I have the number, I can't remember again. I think the well-known port numbers are starting from port 1 to 1023. Then the dynamic, I can't remember it now, but the maximum is actually from 1 to 65,536 or 35, right? So they are broken into that kind of stuff. I can't remember where the category of the dynamic port numbers are. However, for a conversation to occur between a client and a server, there is what is called a socket. The socket is the IP address of the requesting device and the port number on which it is doing the conversation. So those two are put together. So the combination of that IP address and the port number is called the socket. So what we have here is a socket. So this is IP address of the requesting device. Remember we talked earlier here, says capturing package from this client, that's the client, 192.168.78.6. That's what we have here, right? Now, if you see this arrow, it's indicating traffic going to. So traffic is going to this. We don't have this IP address from here, but we're told is the website, and that is the website. The website we type like this. Of course, systems go ahead to what's it called? Resolve those names to IP addresses. So it's been resolved. And this is the IP address. The IP address is 185.199.109.153, and it is HTTP. Now, why is this reading HTTP instead of the port number? Because it's well known, right? So the natural thing here, or the other things you could see here could be the socket here would be 80. So that means this guy is having a conversation on port 80 or HTTP with this guy who is on this port number. Okay, so the flag here is S. Sequence number, this is a sequence, is a window size option. This is called the maximum. This is the size of the traffic itself, and all of this. So this is the conversation happening between them. So this is from client to server. The next one here says this is now the server 185.199.109.153 responding to the client, right? And it captures all of those stuff. This is, again, the client having a conversation with the same server. Now, if you look at all of the values that we have here, for example, here, it begins to explain the conversation that happened between them. But this is just like a screenshot of the discussion happening between client and server, right? Let me see. Great. So okay, great. So they are still doing all of their stuff. So look at here. So here, this is the client, right? Or let's look at this here, for example. This client makes a request, it gets to the server, right? And then here, at this time, the same time here, this particular client makes a request to the server, and here it is saying the type of the information is a HTTP GET. And this is happening on a protocol called HTTP. So it's sending a GET request, which is usually a request to retrieve data from the server, right, to the server. Now, this is the response from the server. Server responds back. This should be an acknowledgement, right? This should be an acknowledgement, but I can't see that here. So here we have a request. This is from the, okay, yeah, great. This is from the server, right, responding to the client, and his response here is a HTTP, right, this is a HTTP response, and this is okay, right? So this is the conversation that they are having here. Now, in the example, you can see the packets that correspond to the steps shown in figure. The client and the server first complete the TCP three-way handshake, which is a synchronization. synchronization acknowledgement, and an acknowledgement. Then the client sends a GET request, right? And the server replies with the TCP acknowledge and the content of the page, which is usually 200 OK response. So here, I'm trying to find, is it me that is missing it? I can't see the acknowledge. Oh yeah, sorry, my bad. I did not notice it. So here we have the acknowledgement. This is acknowledgement. Yeah, oh, okay, I can see them now. I wasn't looking earlier. Sorry, my bad. My bad. So it's typically synchronization request, what we call a three-way handshake, which is a request made from the client to the server. So as explained here, the client sends a GET request after they've completed their HTTP, sorry, their three-way handshake. And by the way, three-way handshake is very important to understand because this is the beginning of the conversation. The SYN, SYN, is a request to synchronize. It's not making requests for data. It's a request to synchronize. This is what makes it stateful, right? Indicating if the person is available and also available for conversation or for communication, then we can go ahead. So synchronization, which is sent by the client, then the synchronization acknowledgement is a response from the server saying, I acknowledge your synchronization. And I go ahead and acknowledge. Then we go ahead and synchronize. Once that happens, it means that the session is open and they can begin to have conversation. Okay. So this is this looks like Wireshark. It is Wireshark. This is Wireshark. Wireshark is a tool that allows you for sniffing. You can begin from here. This is very available. You can download it. I recommend it. Download it. It's not harmful. You just install it on your device, launch it, then tell that application to begin to listen to traffic on a particular port, right? So you can see here, notice the source, 192.168.78, right, is sending, this is the port number in this case, to port 80, right, to port 80. And this is a synchronization request. The sequence number here is 0. The window size is this. The length is this, 0. The maximum, this is the size of the traffic, which is 1460. The window size is 32, right? Now, all of these things are not, so from here to this point are cool. Then the next is the response from the server to the guy. And this is from port 80, because HTTP is on port 80, to that particular port number. And so he's acknowledging his synchronization and also sending his synchronization. So sequence number is 0. So this acknowledgement one saying, I acknowledge the SYN that you sent earlier. The window size here is this, length is this, and all of those. Then the client goes ahead to say, hey, you know what? I also acknowledge your own synchronization. That means you synchronize, I acknowledge, I synchronize, you acknowledge. So we're now good. Then once they are good, the next thing that happens is the client makes, that's what's highlighted there. He now makes his case. In this case, this TCP is for the purpose of initiating that flow control. Once that flow control happens and the session is now open, the protocol that is going to get, right, now comes. So he's saying, please, I want to get, what I'm looking for is HTTP service that is available on 185.199.108.153, but please, I want to see the landing page, which is omar.html. And I'm using the version 1.1. Right? So they go ahead and once this happens, they begin to decide the size of what's going to be carried. Sequence 1, acknowledgement, window size. Right? This guy goes ahead to acknowledge. So this is where they now agree upon, like the example I give of the potato. This is where they now talk about it. So if you click on this at the bottom here, would be that particular, because it's HTTP we're looking at here. If you see at the bottom here, it says, okay, what we're dealing with is hypertext transfer protocol. And this is a GET request, right? And the GET request is requesting omar.html using HTTP 1.1, right? Now, so the host is web.hacker.org. The connection is maintained as a keep alive right now. The cache control, maximum age 0. Upgrading secure request, none has happened so far. The user agent, meaning what the guy is using from his end to make this request. And this happens a lot. Is recognizing that every browser has within it the engine to make this request. So here you notice it's saying there's Mozilla, right? So you can accept this. Macintosh, Intel Mac. There's Apple, right? There's Chrome, there's Safari. Any of these guys can happen. So it accepts, right, and goes ahead to display text in HTML based on the application that it is using, right? And then displays the page. So how does this happen for you when you go to your browser and type cisco.netacard.com and hit enter? This is what happens. Your device makes a request to the server. Why are we bothering ourselves with this? Remember this, we're going to dive into it later and see how these things can be hijacked. But for today, I'm ensuring that our Ladies Foundation as the place to take off from. So if you observe very carefully, depending on the kind of browser you're using, once you launch your browser and you type in the URL, you notice at the bottom where my mouse is actually hovering right now, perhaps bottom left or perhaps the middle or maybe to the right, you see something like website found, and then you see items found. And then you may see 2,000 or 270 something thousand, 66 something items found. Then you see downloading items from site. Then you see downloading 1,000 of this, 2,000 of this, 3,000 of this. What's happening at that point is that your GET request has gotten through. Now, when you also make the GET, once you hit enter, type the address at the top and hit enter, you are making a GET request. But before that page begins to display on your own device, there must be a synchronization that happens from your device through a port number to the service you are attempting to reach. Now, we're dealing with HTTP, right? So you can look at that for FTP, you can look at that for mail, and so on and so forth. However, like I said at the beginning, we must understand that the internet or the network infrastructure is client-server based, suggesting that services must be hosted somewhere. A client will make a request. And each time a client is making a request, depending on the specific service, they have their own methods or a message type, right? That indicates request or response or demand or delete and the rest of them. For HTTP, I mentioned there's get, there's post, there's put, there's delete, there's patch, there is trace, there's option, there's connect. Okay, so this and depends on this. So whenever I'm searching, right, if you see here, you see protocol. So when I see a TCP, I should look at the TCP and try to identify what exactly are they doing. As it stands right now, this TCP is a synchronization request. This particular TCP is a synchronization and acknowledgement. This TCP is an acknowledgement. Who are the guys sending it from here? I can tell the source and the destination. Then I have a HTTP. Look at here. This is also a HTTP between the same guys. This time around, this is 200 OK, indicating that I have sent it. The page has been downloaded. It is OK. 200 suggests that we are good. Okay. So I think we can go on. Right? So attempting to explain, oh yeah, so there they are. I forgot that they were here. Great. Somebody is trying to annotate on my screen. I'll penalize you. You are finding tools to use. I want to believe that you are finding it cool, but it's distorting the content. So if you can undo it, fine. If not, you're a good person. I'll give you a sunny. I'll give you 1 gallon of fuel. Don't worry. Person give you fuel these days, you are good. So the packet that we just saw, right, is shown in figure 6.3, was collected with Wireshark. As you can see, HTTP messages are not designed for human consumption and must be expressive enough to control HTTP servers, browsers, and proxies. So when HTTP servers and browsers communicate with each other, they perform interactions based on headers as well as the body content. The HTTP request shown in figure 6.3 has the following structure. There's a method. We have get, there's head, there's post, there's trace, there's put, there's delete, options, and connect. Right? I explained that earlier. So all of them actually based already. I've explained what they are already. The universal resource indicator, or the URI, some call it URL, right? It represents the path portion of the requested URL. The request version number, which is normally the specific, is where it specifies the HTTP that is being used by the client as 1.1. So then there's a user agent. So user agent in this case is indicating, I highlighted that earlier. And there are other fields that accept language, accept encoding, and other fields also appear. So it would be good to look at it. So this is what we're looking at. So the server, after receiving this request, generates a response. And this is the response that the server generates. It's based on 200 OK. You can see it here, indicating here that, where are we? Yes, status code is 200, which means that we are good. Description is OK. So remember that sometimes we have a response of 404, right? Meaning web page failure, right? And all of this stuff. So those codes are error codes that you may want to study under HTTP. Okay. So let's move on to the details of the response. So one of the things I'll ask you to do is to download Wireshark and establish a connection between your browser and any web server. And then please indicate by raising your hand. How many of you have used Wireshark? If you have used it before, indicate. Just lift up your hand. Let me see. Okay, there are 26 of us here. Okay, great. So I see Adekunle has used it. Yeah, great. Adekunle Tao has used it. Who else? Okay, Tawhid, nice. So it's a very good tool. It gives you an insight into these conversations that we're talking about. Like most of what we're talking about, that it does this, it does that. Okay, Daniel Musa, nice. I know you, yes, of course, of course. Okay, great. Sani. That's cool. It helps, right? Thank you very much. You can lower your hand. So that means the rest of you have not used it before. So here's what I would advise. Just go to the internet, download it, wireshark.org, I think. Yeah, thank you, Adekunle. Thank you. Thank you. So you can lower your hand now. So, okay, great. Dawam, nice. Longmu, great. All right. So download it. For those of you who have not used it, download it, install it, right? And launch it. Once you launch it, it indicates, let me show you what it looks like. Hold on a minute. I'm going to pause this and, okay, hold on. Let me see. So this is Wireshark. After having downloaded, this is what it looks like, right? Now, as we speak, conversations are going on between my system and perhaps whoever is hosting Zoom meeting. My WhatsApp is also on. What else? Maybe some other interaction. My browser is also on. Okay, so let's attempt to. So here you will notice your interface cards listed. So you can see that I'm running some virtual machines here. So I have all of these cards listed here. However, these are the ones that are currently seeing traffic based on the connection to the network right now. So I have Wi-Fi. So I can click on Wi-Fi. Once I click on it, it highlights. Now I can right click and tell it to begin to capture. So you can see right clicking, it says start capture or hide interface. I can do that or click on that, click on the Wi-Fi and come here. You see this guy at the top here? It's like the fin of a shark. So that the shark, so this guy is like a shark inside water. The shark can see everything inside the water. You are able to tell that it's a shark because of his fin outside. So we can tell it to begin capture. Once I click on this, you will notice my traffic begins to capture. See what's happening? So this is what's happening to my traffic. I'm not currently, as it is right now, I am not actively generating any kind of traffic. It's just traffic being exchanged between my system and the various sites I'm interacting with. And there are plenty. So let's say I stop the capture, which is usually what you should do. Otherwise, you're going to just run into trouble. It will keep capturing. This has not been up to a minute, say about 40 seconds thereabout. Look at what we've been able to capture. So it's a very good tool. It's for beginning, it's okay. Now I can go ahead and search for protocols. I'm sure you can see my screen. I can search for protocols. Maybe what I want to look for is TCP. Let's see if I have TCP. TCP, right? Let me search. So I've narrowed it down. This is what I'm looking for, TCP. You can see that I have all TCP sessions here. TCP in collaboration with other things. So this is my IP address. Now this 159.124.38.4. I don't know who that is. But one way you can do that is copy this address and put on your Google and type who is. It will tell you who the guy is. But let's find out who the person is. See, I'm interacting with different guys. So you can see, great. Let's look at this. Let me go to the top of it. So let's look at this guy, for example. This is security exchange happening between my device and some device. 159.124.38.4. Perhaps Zoom. I'm thinking it is Zoom. So I have TLS version 1.2. The length here is 92. This is application data. So this is actually data being transmitted. At the point I capture this traffic, this is data captured. Now this is me and that guy. This is the guy. The source is now hitting the guy, that particular address, and myself, right? So these are all TCP sessions. If I click on one of these, let's say this now, right? Or let's even click on this. I don't know what this place is called now, but it's the area where that displays the details of each of those entries at the top. So I have here for TCP, I can click on it to expand. So it tells me that the source port is 50479, which happens to be my device. Because remember that the source here is 192.168.1.113. So this is the source port. Now the socket would be, in this case, the socket would be my IP address and this particular number. So that's the socket. Now the destination port number is 443. 443 is HTTPS. So it's like a secure connection. I suspect it is a conversation between myself and Zoom. So it says the stream packet, this is number one. The conversation completeness as it is right now is incomplete, meaning it's still ongoing. Is a segment length of 38. Sequence number is 1, right? Blah, 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 blah. So let's go back. So that means transmission control. So as it stands now, we can see this is sequence number 1, acknowledgement 1, length 8. So it's usually a very painful work to be able to capture traffic within a particular time and then look at series of traffic that are related. You can pivot them together and get a detail of what they are saying among themselves. Okay. So the window size. So this is a sequence acknowledgement analysis. Okay. So window size scaling factor is -1. So as it is right now, they are discussing within themselves. I'm sure it's based on the conversation we're having and the slides that I'm sharing. So let me reduce that and go to the part that I want to deal with, which is here, because it's a TLS. From what we have, the protocol here is TLS. Look at TLS. What is it saying? It is a transport layer security. As it stands right now, this is application data protocol that is being encrypted for hypertext transfer protocol. This is a record layer. This is where the information is. So let's see if there's HTTP here. This is HTTP. Do I have any? I don't have any HTTP traffic that's exchanged here. While since I've been doing this, let me see, is there 2? Babu. Is there 3? None. It's just, so all of these are just information that I don't have. Okay, so that's how Wireshark works. You can, let's look at UDP, for example. Is there any UDP stream? Yeah, so I got lots of UDP traffic. So you can see all of them here. This is a conversation happening between me and this guy, you know. So click on this, the data type here. This is the length of the data, and that is the protocol. Port number this, destination port is 8801. So this is most likely a particular, you can go ahead and search what application uses port 8801. I suspect it is either WhatsApp or Zoom. Somebody can just quickly help us check. Moku see how far. Port 8801. Somebody checking? Aha. I suspect it is Zoom. This is a registered port number. Has anybody found it? 8801. Anybody? Just trying to get you to interact because I suspect it is Zoom. I think I know it is Zoom. But I just want to, anybody? Has anybody been able to find it? Nobody. Just search for port 8801. Oh yeah, nice. Zoom. Yeah. I suspect it's actually a port used for, yeah, thanks. Thank you. I suspect it's the port used for media connection. Yeah, media connection, right? So yeah, so there. So you can find a lot of things here. These are preliminary. These are just findings, not testing. We cannot launch any attack with this. This is for analysis. Okay. So let me go ahead and shut this guy down. Let's go to slides. Okay, so that's that. That's for this particular. Let's move on to other things. Okay, yeah. So these are the messages for HTTP, right? And what it means. Sorry, let's get back. The server includes a 3-digit status code. Remember, 200 means that successful transaction, right? So you can see there's a 100 range, 100, 101, 102. Those are usually informational. Then there's a 200 range, which normally are related to success, right? So whatever value it is that you have, just get it and search. It's with proper interactions with them. It's the HTML code, right? And that's actually the server telling you some information about the content of the website. So 300 are related to HTTP redirection. So each time you would notice, for those of you that do those transactions that purchase NEPA unit using it online, you can try it on your system. Launch Wireshark, go to buypower.ng or whichever one you use in your area, then go to purchase power. Your HTTP will capture it. Your Wireshark will capture it. Then at the point of payment, of course, it will redirect you somewhere to impute the details of your card. See what happens there. You would see the 300 category. The 400 is related to client error, right? 404, 401, 403, all of those things. Then 500 relates to server error. So sometimes somebody walks your system and sees some code, say, okay, this is in your system, check. Say, no, the server is down. That's because they have an idea of what these codes actually display, right? So this is the structure, and very likely this is where we might be ending for today, right? But let me just try to go through it and then see how we can do the rest of them. So HTTP protocol structure. I don't know what's happened to my screen. It's looking as if the thing is, I don't know what's happening. I don't know what I touched to. Okay, it has gone. Okay. So we're looking at the URL structure. HTTP and other protocols use universal resource locator, right? And you're familiar with the URL because you use them every day. That thing you type there, this is a URL. This whole stretch is a URL. It has some other additions to it, and we can try to explain all of this. It's very important. Why? At the point where you are being redirected, some of these things are captured, and you're able to tell what's happening. Are you being redirected? Are you being directed? Is somebody trying to infuse something into this? Is somebody trying to, display something beyond what you're supposed to have? Now, this section explains the element of the URL so you can better understand how to abuse some of these parameters and elements, so you can better understand how people abuse it or how you can use it from an offensive security perspective, right? So consider this URL, https://the-art-of-hacking.org:8123/dir/test:/ID equal to 89 question mark, name equal Omar and X equal true. We can break down this URL into its component parts. Number one, there's what's called the scheme. The scheme is the portion of the URL that identifies the protocol that is being used, right? And usually it's normally followed with a colon and then 2 slashes. So this case, HTTP colon here indicates that we're using HTTPS here. Okay. So in this example, the scheme is HTTP. The scheme, of course, is the step-by-step approach. So how is it doing it? It's using this via the instruction or the technique. Scheme is a technique, right? Technique of approaching them. Then there's the host. The host is normally either an IP address or a name or a combination of both of them. So this is the IP address, numeric or DNS-based. DNS-based is normally like a name written this way. It could be numeric as per IP address for the web service that is running on that device called the server that you're attempting to access. It usually follows after the HTTP :// what follows is usually the address. In this case, the host is the artofhacking.org. Okay. Then there's the port, which happens to be in this case :8123. This is optional, right? However, it designates, because sometimes it might be displayed, it might not be. It designates the port number to which the target web server is listening. The default port number for HTTP is 80, but some configurations are set up to use alternate ports. In this case, it is using 8123, and is anything within the range of 8,000. Okay, so those are the alternate ports for some of this service. So in this case, this particular guy hosted his service by 8123. Then there is the path itself, which is anything from this part, right? The DR is a directory. This is normally telling you, directory is what we call a folder, okay? Normally, it indicates the root where that particular thing you're going to get is actually hosted. So you know that I'm sure you all know that every server that displays whatever service contains a folder that has all of the things you're trying to get. It's just that there's an application that helps you display those things in a format that is web interactive. So this is the path route from the root directory of the server to be desired resource. In this case, you can see that there is a dir, a directory called dir. Keep in mind that in reality, web servers may use aliasing to point to document gateways and services that are not explicitly accessible from the server's root directory. So remember that this particular server was built for this course. So that's why it's showing you that this is the directory. It shouldn't be displaying it this way, right? Then there's the path after the directory, which is where the store, what you're looking for is kept. So we're using this scheme to access this server on this port, and what we're looking for is in this folder, right? Then there's the path segment or the parameters. This is the portion of the URL that includes the thing that you're looking for, typically preceded by a semicolon. So you see a semicolon here, right? So this directory or this folder we're using is actually a test directory. That's the folder. Then everything that we're looking for is this. It's an ID equals 89 with a name equal Omar. And once that thing is true, then the page displays. So in this case, the path segment parameter is ID 89. That's what we have here. Path segment parameters are not commonly used. In addition, it is worth mentioning that these parameters are different from query string parameters, often referred to as URL parameters. So we can query certain things. Normally it should maybe omar.index or index/html. Okay. So I think so far we have 7 more minutes to the end time for the class. So then there's a query string. Yeah, okay, yeah, this is a query string. Yep. So this is the name Omar. The query string in this case is name Omar. So if this is true, then display. There's the ampersand, which is the and marks the boundary, the name and the value. So here, Omar and this particular value. So together, the name is equal to Omar ampersand X equals true. In addition, other protocols such as HTML, which is hypertext markup language, and CSS are used on things like SOAP or Simple Object Access Protocol, and RESTful, this is where we're going, APIs. Examples include JSON, XML, and web processing services, which is not the same as WPS in, of course. WPS in wireless network is wireless to just preset your SSIDs and the rest of them. So that's where we're going to stop for today. Tomorrow we'll continue from there, and then by tomorrow we'll just go downhill. We're going to just conclude the rest of them like in a hurry, because I've actually laid the foundation I require to do here. So this typically what happens, what we just saw now, right, is to say that the moment a client makes a request, this request is based on synchronization. The server acknowledges, and then server sends its own synchronization. The client acknowledges. They are now, three-way handshake is complete. Then they can go ahead and begin all of this. So it says, get this particular omar.html. The server responds, and then based on what it is written as, they keep responding the script and all of those things. Eventually, once we are done and the guy closes the website, then the connection is closed. So this can happen as many times as possible. Okay, that's what we're just simply saying here. There's also, yeah, in this is multiplexing 2.0. This is for HTTP 2.0. Typically collecting more than one script on one page displayed. Okay, so we'll start from here tomorrow, and then we'll spiral down and conclude this chapter. So we're going to look at, so one of the tasks that you have to do is to practice the HTTP protocol. Just download your Wireshark and practice. We'll start tomorrow with web sessions. Then we'll conclude. Unfortunately, if we don't exhaust all of it, the rest of it I'm going to give to you to read and perhaps um, have discussions with me over. Then we're going to dive into the top 10, OWASP top 10. We talked about them already. We just list them, and like I said, we're going to spiral down through them. We're going to go into discussing these guys. There's a lab for all of those things and how to build your own lab. Then we'll dive and continue because the rest of them are like very straightforward like that till we get to the end. All right. So that will be all for today. We're starting from here tomorrow, web session. So we're going to start from. Thank you all very much for your time today. I hope to see you tomorrow. Thank you. The turnout today is encouraging. Are there any questions that you have to ask? Maybe some clarification that you require? Thank you, Ebo. Thank you. My pleasure. Thank you, Dom. Thank you, Longmoon. All right. So we'll see tomorrow.